find complex numbers, think slash one, can you remember what I is equal to? Isn't that I? Yeah? Imaginary, what's it equal to? No, -1 is a real number. Because we can't take the square root of a negative number, at least when we're talking about real numbers. Now, Leo said a word that it is called that I hate. Imaginary. Well, then I'm probably going to give a very similar spiel. Imaginary does not mean made up. It does, but this number exists. I hate that they call it imaginary, because when you call something imaginary and then you teach it, math is already a subject where like, why the heck are we doing the Pythagorean theorem? When am I going to need that? And then you call something imaginary, and then it's like extra what the heck? Why? If it's imaginary, what's the freaking point? Oh! Imaginary numbers are very real. They exist. We just call them imaginary. I much prefer complex numbers, right? It's kind of like at some point in time, people thought negative numbers were stupid, because why would you need a negative number? You can't have a negative amount of things, until you start talking about currency and money. Then negative numbers start to make sense, right? Just like how this might not have an application like directly in our heads right away, imaginary numbers are massive, huge, because imaginary numbers find roots of everything. When I say roots, you know how on a graph, we used to find, quadratics, and then you'd factor them and you'd get these roots, or you'd do the quadratic formula and you'd find those roots where it equals 0. Well, what happens if it's like that and it doesn't cross? Then it has imaginary roots, and they're very important and very real world. And you can turn imaginary numbers into real world numbers. And then there's even this beautiful equation that sums up all the important math numbers in the world. I think it's e to the I pi equals 1. Or I think a better way to even write it is e to the I pi minus 1 equals 0. I think that's what it is. I don't know. It's close to that. E is just a number like pi. Like pi is 3.1415, blah, 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 blah. E is just a number, it's 2.7 garbage. That's my short spiel. Imaginary numbers are very real. If you like your phones and you think imaginary numbers are stupid, go throw your phone out the window right now. Because without those, ain't no way your phone's working. Okay, so we have I is equal to the square root of -1. Then I squared equals -1, right? Square kind of undoes a square root. Now this is a little iffy, because when we're talking about real numbers, if we said the square root of 2 and then we times it by the square root of 3, we said, well, you can combine those, that's the square root of 2 times 3, which is the square root of 6, right? But if we did that here, the square root of -1 times the square root of -1, well, then we could say that's the square root of -1 times -1, which is +1. The square root of +1 is just 1, right? But that's -1. And that's because when you're dealing with different things, right, we're not dealing with real numbers anymore. We're dealing with complex numbers. There are different rules. I squared is -1. Basically, you take away the square root. I cubed, so I squared times I, -1 times I is just going to be -I. All right, if you have I as the square root of -1, you square it, that undoes the square root. You times it by I one more time. -1 times I is just going to be -I. You times it by I again. And then you get -I squared, really, right? If I times this by I again, I'll get -I squared. Well, I squared is -1. So -1 is +1. And then it starts over. right? If I times it by I again, 1 times anything is itself, or the square root of -1. And then if I times it again by I, then I get I squared, which is -1, or I to the 6th, then I get 1 times I squared, which is, and it keeps going, right? I to the 7th, I to the 8th, and so on. So, if you want to find the value of I to the whatever, it's going to be one of these. And there's a very easy way to find it. You divide what the power is by 4, and then you look at the remainder. I would write this little graph down and say when you divide n by 4. So if I had, I don't know, I to the 404, I already know that that's going to be 1. Because 404 divided by 1, or 404 divided by 4 has a remainder of 0. And look at this pattern. What this pattern would be: I to the 4th, I to the 8th, I to the 12th, right? If I kept doing multiples of 4, I would get 1. 4 is a multiple of 4. 1. Now maybe with like a smaller number, maybe if I did like, I don't know, let's do I to the 22nd. If I divide that by 4, right, I get a remainder of 2, oops, which from this graph is -1. But why? Well, that's because when you divide it by 4, essentially what you're saying is that's I to the 20th times I to the 2nd. I to the 20th, a multiple of 4 is 1. Anything that's a multiple of 4 is 1. 1 times I squared is just I squared, and we know I squared that's not a negative sign. -1. That's why it works. Okay? So I to the 53, what's the remainder when you divide 53 by 4? You don't actually have to do the division in your head, just get close, right? Like 40, 44, 48, 52. Remainder is 1. When the remainder is 1, I of the n equals I. Or the square root of -1. But you can just leave it as I. -13. What's the remainder when you divide -13 by 4? -1. Problem. Is there a -1 here? Yes. I think another way to think about it is there's another way to think of remainders. So your remainder was, okay, you got to 12 and then -1, right? But what if we go to -16, right? It goes in there -4 times, and we go to -16, and then we add +3. Yes. Well, the negatives, so the negatives are a little, I like to think of them a little different, right? Not just divide by 4 because then you would get to 12 and then remainder -1, but we don't have a -1 on our chart. And if you're good at thinking about, you know, that -1 is like right here 0, so -1 is really going back up to here. I assume, is that how you were kind of?
I was looking at R equals 1, and then it's just negative, because the remainder would just be -1.
Yeah.
And then it would just be, if R equals 1 is equal to I, it would just be R equals
Yeah. Because this is kind of like going in a circle, really, right? I have it listed like this, but it's really going like in a circle. And so, yeah. So if you were to go backwards from 0, you'd really be here. But I like to think, okay, if you go in there 4 times, the remainder is then +3, right? Like if we were to do long division on this, and I said this one in here, -4 times, -4 times 4 is -16. Subtract, minus is really adding, so remainder of 3. 13 plus 16. Remainder of 3. Oh, and when it's a remainder of 3, -I. Yay.
Just the way that I work, that I thought that was what it worked
I would assume so.
out. Okay.
I mean, you got the right answer. I was a little lost, but that's fine. If it makes sense in your head or other people's heads, then that's fine. Okay. You don't have to write all this crap up here. So a plus bi is considered to be in rectangular form, right? We've been dealing with polar. Why is it considered rectangular form? Well, that's because when we have, when we're talking complex numbers in the complex plane, instead of x and y, we have the real value and the imaginary value, right? So a plus bi is rectangular because then we go real value, right? And then imaginary value, much like we do x and y. When we're adding and subtracting and multiplying, we can basically follow all the same rules as we do with real numbers. And that's just combining like terms, right? Be careful. You see parentheses here? You guys are used to multiplying those. Look at what's in between. Is that multiplying? No. They separate them like this because that's how we like to write complex numbers. Like they like to say that that's one complex number, right? And that's 1 because you have your real part and your imaginary part. That's like one complex number. Well, this is pretty easy. 5 plus -2 is, and -3 plus 4i is, or -3i plus 4i is, plus 1i or plus I. Okay, that's it. This one, be careful with your negative. 10 minus 14 is -4. -2i minus -6i is +4i. That's it. Oh, these ones are multiplying. Two times 7 is 14. 2 times -4i is -8i. -3 times, or -3i times 7 is -21i. And -3i times -4i is +12i squared. -14 minus 8i minus 21i is -29i. Oh, but hey, I squared is what? -1. So 12 times -1 is really just going to be -12. Right. And then we can do 14 minus 12 is